Welcome to section 2.5, where in section 2.4 we only dealt with the sine and the cosine curve, which in essence look pretty much exactly the same. And in section 2.5 what we're dealing with are all the others, the tangents, cotangents, secants, and cosecants. Now they can be broken up into tangent and cotangent look very similar. Cosecant and secant look very similar, and both of them can be done and analyzed in pretty much the exact same way. So let's begin with example number 1, where we have y equals 3/2 tangent of x. Now, according to what is in the book, and you do need to get familiar with these particular graphs to see what each one of them looks like. We have the tangent of x, which has a very distinct look, but even really more importantly is the fact that there are those vertical red dashed lines which are called asymptotes, and it's very important to understand or to realize where those vertical asymptotes are. And so if I draw my graph, but notice the same thing is going to apply, and we're going to still continue with 2 pi and pi. Now for tangent, we notice that the vertical asymptotes occur at the halves, at the pi over 2, the 3 pi over 2, so on and so forth. Okay, now a normal tangent curve will go through the point 0, 0, and it will go up in this general direction like this. But these asymptotes, it will never reach those asymptotes, it'll never cross it, but it will get progressively closer and closer. But basically tangent curves will look much like the way the pen is being drawn right now. Now a normal point is at pi over 4, or in other words halfway between this mark and this mark right here, pi over 4, 1. But we do have a slight problem. We have this 3/2 here. So that does throw it off just a little bit. But each of these bars, I guess we can call them, it's going to go through the middle point right there. So there at 0, 0, here at pi 0, here at 2 pi 0, and it would happen every pi from then on. And realize if we do the next mark, we would get yet another asymptote right here. So we do want to go through at least one cycle. Realize that one of these bars is one cycle, but on tangent and cotangent, generally we like to see at least 2. So that is one exception. But once again, normally halfway between here and the asymptote, it's pi over 4, 1. But we have to deal with this 3/2. 3/2 deals with the amplitude. So instead of pi over 4, 1, we're going to go up to 3/2. So it goes there. And that will be true in each of these cases. From the point to the right will be there and there. Now of course the same thing applies on the negative end as well. So between this point and the left asymptote, normally it would be negative pi over 4, negative 1. But we need to go to the 3/2. Now we need to create a nice smooth curve through here that looks something like that. And this isn't very smooth, but that's what happens when I try to draw on the computer. And it's going to look more or less something that looks like that. And notice if this one were drawn a little bit better. In fact, it needs to be drawn just a little bit better. Notice each of the bars have the same general look. And so what I'd be looking for, making sure that you get the zeros in the right spot and that you have this at the appropriate level. At, in this case, 3/2 and negative 3/2. Example number 2. example number 2 is y equals negative cotangent of 4x. Well, we have a couple things we have to deal with. First of all, this is a cotangent, and so we need to look at how does cotangent differ from tangent. And we have the 4 that we have to deal with, so that will affect our period, so we need to deal with that. And we also have this negative, which affects the reflection. And this negative is going to be affected in the same way that it does in algebra. The negative does not directly affect the x, and so it will be reflected over the x-axis. And so we need to understand that particular relationship. But let's deal with some of the other things. First thing we're going to deal with is that 4. Now, the 4, a normal period for cotangent is pi. And so, whereas last video we dealt with 2 pi over omega, what we're going to deal with now is pi over omega. And so what we want, or every period is going to be every pi over 4. And so what I'm going to do is I'm going to create where every other mark is pi over 4. Now, tangent had vertical asymptotes at negative pi over 2 and positive pi over 2 and 3 pi over 2 and so on and so forth. Cotangent will have asymptotes at the y-axis, and since our period has changed to become pi over 4, it's going to be at every pi over 4 as well. So the way the graph is set up, it's basically every other mark. So here we're going to actually have, what, 5 different cycles or 5 different periods going on. And cotangent normally will go halfway between the 2 asymptotes. We'll go through the 0, 0. So we'll have those points right there in each case. And normally, if this negative wasn't here and if there wasn't a number here, from the center point to the left asymptote would be the point, halfway to the value of 1. And on this side it would be halfway from the point to the right asymptote to the negative 1. But here, since we have this negative, we're going to reflect it over the x-axis. So what would normally be right here, we're going to put right here. And that's going to be true in each and every period. Now normally, on a normal cotangent curve, it would be from the center point to the right asymptote would occur down here at the negative value. But instead, since we're reflecting over the x-axis, it's going to go there, as well as each and every period forever. And remembering that cotangent and tangent are going to look very similar. We will get something that looks like this. Notice this basically looks like number 1. What's different is all of the values and where the points are, and the period and the asymptotes. Those are the big changes, and those are the things that you need to be concerned with. Example number 3 is y equals the cotangent of x minus 1. Okay, the only thing that really strikes out at me is that minus 1. And just like in algebra, when we have that minus 1 that is not directly affecting the x, it's going to be a shift either up or down. So we need to take that into consideration. Cotangent tells me every pi over 2 is a new cycle. So, or I'm sorry, every pi is a period. So I'm going to let each mark be pi. I'm sorry, each mark be pi over 2. So every other one will be the integer values for pi. And I need to first of all write my asymptotes, or show my asymptotes. My asymptotes begin here because we are talking cotangent. So I've got that one, and then every period after that will be another asymptote. So in this case, I'm going to show 3 periods. The middle point is the 0, except our 0 bar is going to actually be moved down by 1. So this becomes my new 0 line, so to speak. Now that's not an official mathematical term, it's just a way to help you get through these particular problems. Okay, now cotangent, we know the middle point is at the 0, so that'd be there, there, and there. And cotangent also, between the left asymptote and the middle point, the value is halfway at 1, unless the amplitude is different. But in this case, the amplitude is 1, so it's going to be halfway, which is about right here, 1. 1 up from the 0 line, which is right there. And that's going to be true in each and every period. Finally, between the middle point and the right asymptote, the normal point is halfway between and the negative 1. So I'm going to come down here to which is actually the value of negative 2, and that's what's going to show up there. And so we've got these 3 important points, and it's important to realize that this is going to look like an inverted tangent, but it still has the same general shape as the tangent. So there we have the graph y equals cotangent of x minus 1.